Hello again. Today we're going to learn how to represent combined probabilities. It's very important to recognize which way we're going to represent the probabilities depending on the context. This is going to be very useful to recognize the probabilities of each of the events that we have in the experiment. The first representation that we're going to talk about is list. In this one, what we're going to do is just write the possible outcomes that we have in our experiment. So let's say that the experiment is going to be throw a dice. The universe is going to be equal to 1, 2, 3, 4, 5, and 6. Now, let's think that we have two events. The event A that is going to be thrown an even number, and the event B that is going to be thrown a prime number. So, if we wanted to know which ones are the possible outcomes of this event, so we just have to write which numbers in our sample space have this condition. So, the events that belongs to A are 2, 4, and 6. Now, the events that belong, or the outcomes that belong to B are 2, 3, and 5. Now the probability of A is going to be 3 over 6 because we have 3 elements in A over 6 that we have in total. This is equal to 1 half. And the probability of B is going to be exactly the same, 3 over 6 equal 1 half. Next representation that we're going to use is the Venn diagram. So it is important to recognize that the Venn diagram is like the sample space represented as a rectangle. So every time that we're going to represent our universe, we're going to draw a rectangle. The experiment that we're going to use to show this representation is throwing a dice too. So our universe is going to be this rectangle. We're going to write the U inside of it, and the event A is going to be also thrown an even number, and the event B is going to be also thrown a prime number. So here I'm going to represent the event A and the event B as two circles. One of the circles is going to be A and the other circle is going to be B. And the first thing that I'm going to do is that I'm going to write inside of the circles, the elements that each of these spaces have, okay? So I'm going to start with the intersection because it's the thing that they share, right? So the value that is in the intersection is 2. So now I'm able to write the other values, okay? So the other values that belongs to A are 4 and 6. Those are all the even numbers. Now the B, the prime numbers are 3 and 5, and there is one number that doesn't belong to each of these events, which is 1, right? So this is pretty much what we do. The probability of A is going to be equal the total amount of elements that we have in A, which is 3, over the total elements that we have in the universe, which is 6. So, well, now let's say that we're going to find the probability of A intersected B. So, because it's the intersection, well, I have only 1 over 6. Don't forget to simplify, so here we have 1 half, and that's it. Now we're going to see how to use the sample space diagram. This one, it comes very handy because of the form that it has. It looks like a table, so allows to see all the sample space. So depending on the context, well, it's going to be very useful, okay? So now we're going to think for this experiment that we're going to throw 2 dice. So we're going to write horizontally all the possible outcomes of one of the dice and vertically all the possible outcomes of the other dice. So here we have 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, and 6. So let's say that the event A is going to be sum is a prime number. So, well, to find the possible outcomes of this, so we're going to add the the, the outcomes, right? 1 plus 1, 2, and so on and so on. Okay, so here we're going to have 3, 4, 5, 6, 7, 8, well, and so on. Okay, very good. Here, this one is 8, 12, sorry. So, well, now we're going to identify which of these events that we have here are prime, right? So we have 2, 3, 5, 7, 3, 5, 7, 5, 7, 5, 7, 7, 11, 7, and 11. So now to find the probability of A, so what we have to do is just count how many of these ones do we have, right? So here, well, we have 15, right, over 36. And that's it. A tree diagram is another way to represent all the possible outcomes of an event. So here we're going to do this experiment that we're going to toss a coin twice, okay? So to start this representation, so we're going to think that the first time that we throw the coin, we have two possible outcomes, right? Or head or tail. Now, if we toss the coin again, so we're going to have head, two possible outcomes for head and two possible outcomes for tail. So we're going to have head or tail or head or tail, right? Now, remember that in this one, the end of each branch represents the combined event. So here, if we go this way, we get head and head. And if we go here this way, head and then tail, so we're going to have head and tail. Or in this way, we're going to have tail and head. And then, well, we could have head, tail and tail, right? So for each of these events, first tossing a coin, we're going to find the probability of each of them. So if we toss one coin, the probability is going to be 1/2 and 1/2. Remember that if we add these probabilities, have to add up to 1. Okay? Now we do exactly the same for the other one. So we have 1/2 and 1/2 here for tail and 1/2 for head and 1/2 for tail. Now, because this one is a combined event, okay, so the probability of this combined event is going to be the multiplication of the probabilities, right? So here we have 1/2 times the probability of 1/2. So this one is 1/4. And we do exactly the same for the other one. So we have head 1/2 and tail 1/2. So we multiply them, and that is equal to 1/4. And here it's 2, 1/2 times 1/2 equal 1/4, and 1/2 times 1/2 equal 1/4, right? So now let's say that we have an event that we're going to go um, having at least one head, right? So, well, we have to see when this occur, right? That we have at least one head, right? So that means that we can have or one or two, yes, but at least one. So when this happened, here two, right? We have one head, but in the other one. So to find the probability of this event, we have to add all of these probabilities. So we're going to write add 1 times 1/4 plus 1/4 plus 1/4 equal 3/4. And well, this is how we find the probability of this event. I hope you all understand and see you next time. Thanks for watching.